Eos's Renewable Energy Knowledgebase is designed for estimating wind farms, solar installations, energy storage, and electric vehicle charging stations. The Knowledgebase contains a model for quickly taking off solar farm PV panels with fixed tilt mounting systems for your estimates, as well as cost models for electrical service, transmission and distribution, and site work. Let's take off the solar farm PV panels model for a 3.7 megawatt solar farm. For the model reference, assign a special reference ID to the model or use the current date timestamp that pre-fills. If there are conditions that will affect the labor productivity for the project, you can adjust the productivity for the takeoff as needed. The model includes helpful graphics to give you a better idea of what it provides. When you don't want to see the graphics anymore, you can hide them by clearing the checkbox. This graphic helps illustrate the way that panels are typically arranged in a solar farm. You can use multiple arrays to add more power output to achieve the desired target output. The model interview arranges modules and tables and strings. You can have one table and a string if you want the smallest assembly of modules to be a string. Strings are assembled into rows and rows into arrays. A simplified equipment wiring diagram is also provided. The model interview builds up the details for a solar farm and calculates the power output and site size requirements. If you have a target power output or target site size, you can adjust the details to meet those targets. Let's start by specifying the PV panel modules to use. The Knowledgebase contains generic modules for different voltages and power ratings. In this case, we're using 48-volt modules and starting with a 425-watt rating. The typical dimensions pre-fill for the modules. You can change any of the dimensions as needed. This graphic shows one example of a fixed tilt racking system. The interview questions are based on this racking system type. The table arrangement provides different ways to create a grid of modules on a rack connected in a series. At this time, the model supports only the portrait orientation. The default questions ask you to supply only the number of panels high by the panels wide, and the model calculates the resulting output voltage and power. The model provides 1500 volt inverters, so the target voltage is about 1500. Selecting this checkbox shows all of the assumptions and calculated values. The string arrangement contains one or more tables connected in parallel. The model calculates the resulting power per string. Next, the strings are arranged into rows to form an array, and the output power for the array is calculated. You may need more than one inverter per array based on the inverter limit. The array collection wiring brings all the row outputs to the inverters. The inverters change the DC current to 3-phase AC current at 600 volts. The step-up transformer converts that to a higher medium voltage, nominally 13 kilovolts. The 13 kilovolt lines can be connected to form multiple arrays to provide the 13 kilovolt power output from the farm. In this example, the desired farm output is reached at 3.7 megawatts, but you can adjust the values in the interview as needed to obtain the desired output power. With the necessary arrays in place, the model calculates the minimum required area for the solar farm site. Again, you can adjust any of the values as needed for your project. Does the site need cut and fill or grading? You can add this work to your estimate. You can also include clearing, a new access road, and fencing for the solar farm. And that completes our takeoff for the 3.7 megawatt solar farm. Next, let's generate the model to the estimate. Let's take a look at our Takeoff. The model assembly spreadsheet sequence shows the results grouped by model and assembly. Here's the solar farm model. The total cost with add-ons is approximately $2,040 per kilowatt. Estimating a solar farm is as easy as completing the interview for the solar farm PV panels model and generating it to the estimate spreadsheet. Your estimate will contain details for the necessary PV modules, racking, wiring and grounding, combiners, inverters, step-up transformer, clearing, grading, cut and fill, erosion control, access road, and fencing. And you can add other models, assemblies, and items for any additional scope that's needed, including energy storage, distribution lines, and connection to the grid.